Right, I told a little lie when I said question 9 was the last one, because this one is. Missed it out. Question 10, I think this is a really nice question. 11 marks, but there's nothing difficult as long as you know your coordinate geometry, which you should from core 1, and the general equation of a circle, which is really, really straightforward and easy peasy. So, circle C has centre A, 2, 1, and passes through the point B, 10, 7. Find the equation for C. You can draw the diagram out if you want. We might need it later on, so let's have a go. You've got the point 2, 1. 2, 1 is here, and that is the point A, and that's the centre. And it passes through the point also 10, 7, so that's about here. That's point B. So it's a circle with that centre. This is going to be lovely. Wee. And there's your centre there. We want the equation for that circle. You need to know the general form of the equation of the circle. So part A, general form of the equation of a circle is x minus a squared add y minus b squared equals r squared. It's taken from Pythagoras, where a and b is the centre of the circle, so we know that straight away. A is the x coordinate, 2. B is the y coordinate. Don't forget your squares. And r is the radius, but they leave it in r squared. So we need to find the radius of the circle. We need to find this bit here. But you can find the distance between 2 points. It's GCSE grade C. It's not difficult. You can sketch the diagram if you want and show that you're using Pythagoras. This is the distance between 2 points. You need to work out this distance and this distance, which is the difference between the x and the y coordinates. I don't draw the diagram. I just look at the x coordinates, find the difference between them. So the difference between the x's, 2 and 10, is 8. So for Pythagoras, we're doing 8 squared plus difference between the y coordinates, 1 and 7, that's 6. So the distance is 6. So you're finding the square root of 64 plus 36. This is nice, which is the square root of 100, which equals 10. So this distance is 10. So because it's r squared, remember, that's going to be 10 squared, which is 100. So, just so you can see it, this is the final answer for the general equation of this circle here. Now, part B, we may have to go on to another page. We'll see what it asks us to do. The line L1 is the tangent to C at the point B. So tangent, there we go. That's the line L1. Find the equation for L1. Right. The only thing that you need to know for this to make this question doable is that the tangent to the radius is always 90 degrees. So a tangent to the radius is always 90 degrees, which means you can find the gradient of this line, because we can work out the gradient of this line because we know A and B. So I think we should be able to squeeze it on the bottom here. We're finding the equation of L1. It's a straight line, mx plus c. Find the gradient, and then it's dead easy to find the point C, because we know a point that lies on this blue line, 10, 7, and we'll substitute it in. The gradient first. We need the gradient of this black line first. So the gradient of the black line, we'll just do it here. It's y take away y divided by x take away x. So the gradient of this line is 7 take away 1 over 10 take away 2. 6 over 8 3/4. So what that means is the gradient of the blue line, the perpendicular line, is -1 over 3/4, which is just -4/3. Remember, you flip the fraction and change the sign. So now we've got y equals negative 4/3 plus c. To find c, you substitute in any point that lies on the line, and we know the point that lies on the line is 10, 7. So 7 is the y coordinate, so 7 equals minus 4/3 times x, which is 10, plus c. Ooh, running out of space, we'll have to do it here. 7 equals minus 4/3 times 10. You can use a calculator for this, but that's minus 40/3. Plus c. So c equals, take the minus 40/3 over, so you get 40/3 plus 7. I'll just use a calculator. 40/3, that's 40 divided by 3. Add 7, and we'll get 61/3. So although very, very messy, I can say the final for B, the equation for L1, y equals, the gradient was negative 4/3 x plus 61/3. If I wanted it in a nice form, I times everything by 3, but we'll not bother with that now. Right, now this last part, I think we can probably do on here, but I'm going to rub out the stuff that we won't need. So we don't need any of this. We don't even need the equation. We don't need this gradient bit. You'll see why I'm getting rid of all this in a minute. I'm going to get rid of this too. There we go. And that. Right. Now, this question, there's a couple of ways of doing this, but it's only 3 marks. And the way I first thought I was going to do it, I knew it couldn't be the easiest way because it was going to take a lot more work than 3 marks. Right. We've got the line L2. It's parallel to L1, but it passes through the midpoint of AB. So the midpoint is about here, but it's parallel. And that there is L2. Given that L2 intersects C at the point P and Q, so let's say P and Q, find the length of PQ. So we want the length of this red line. Now at first I was thinking I was going to have to find the equation of the line, then find out what those points were by doing simultaneous equations with the circle, and then once I knew the points I could find the distance between them, but that would be worth a lot more than 3 marks. So there must be another way, and I'm going to show you it now. What you have to spot is that you've actually got a rhombus. I'm running out of colours here. Let's go with a highlighter. We've got a rhombus because this cuts this in half and it's parallel to the blue line. That means it's also perpendicular to the black line like the blue one was. So this is 90 degrees here, and we've got a rhombus. So oops, let's make a nice straight line. Now the properties of the rhombus are that we've got right angle here. Now what we need to find is this distance here, remember. But if we can find this distance here, then we can just double it to find that one. Now we can find this distance PO because we know what this is. It's half the radius, and we actually know what this is because this is the radius. If I get another pen, running out of room here. This is the radius because remember this is the center and this is the outside, so this is the radius, which was 10. This here, because it's the midpoint, it's half of the radius, so this is 5. We're focusing in on this right angle triangle here, so we can work out this distance here, PO, by just using Pythagoras. That's the hypotenuse, that's the shorter side, so square and subtract. So PO equals 10 squared, subtract 5 squared, all square rooted, which equals the square root of 100, take away 25, which is root 75. Because they want the distance PQ, that's double that, because it's twice the distance. It's from there to there. So it's 2 lots of root 75. Now it says, if you can see it, find the length of PQ given your answer in its simplest third form. So we need to simplify this. Root 75 is 25 times 3. So root 3 times root 25. Because 25 times 3 is 75. So you end up getting 2 times 5 times root 3, which equals 10 root 3. So you'll get 1 mark for simplifying it and 2 marks for working that out. Easy maths, but I think it's quite hard to spot the quick way of doing that. Now that is the last question.